Hello guys, welcome to my channel, and this is our lecture 4 of linear algebra. So today I am going to discuss intersection and union of subspaces of vector space. So as you know guys, all the topics of vector spaces are useful in all competitive exams like GATE, NET, which involves higher level mathematics. So let's start with our topic, that is intersection and union of subspaces. So just write down first result, that is intersection of two subspaces of a vector space is a subspace. So this is our first result, and this thing we have to prove. So first of all we have to take two subspaces, like let W1 and W2 be two subspaces of vector space V. And what we have to show? We have to show that W1 intersection W2 is again a subspace. So we can assume it as W. W is equal to W1 intersection W2 to prove be a subspace of V. So in order to show that it is a subspace, what we have to take? We have to take two elements from this, and we have to show x plus y is also belongs to W. And for second part, we have to take alpha belongs to field and some x belongs to W, and we have to show the scalar multiplication part. So this alpha x also belongs to W. These two things we have to show. So let's begin with first part, this thing. So let's prove that xy belongs to W. This means xy belongs to W1 intersection W2. So we can write this as x belongs to W1 and x belongs to W2. Y belongs to W1 and y belongs to W2. So guys, from here, if x belongs to W1, y belongs to W2, and as you know that W1 is a subspace, so we can write x plus y belongs to W1, and from here, as x belongs to W2, y belongs to W2, W2 is a subspace, so their addition is also belongs to W2. So now x plus y belongs to W1, x plus y belongs to W2. So we can write this as x plus y belongs to W1 intersection W2. So hence proved first part. Now we proceed further for second part. In second part, alpha belongs to f and x belongs to W1 intersection W2. So we have to show alpha x belongs to this. So from here, what we can write? X belongs to W1 and x belongs to W2 using definition of intersection. So as you know guys, W1 is a subspace. So what we can write from here? This implies alpha x belongs to W1, and from here this one, alpha x belongs to W2. So again we can write alpha x belongs to W1 intersection W2, which means the scalar multiplication part is also verified. That means we can say that W1 intersection W2 is a subspace. So any intersection of two subspaces is a subspace. Now we have to prove next result, second one, that is union of two subspaces need not be a subspace. So as intersection of two subspaces is a subspace, but for union this result is not true. Union of two subspaces need not be a subspace. So for this there is a result, union of two subspaces is a subspace. There is a condition, if and only if one subspace contains other. That means in mathematical form we can write W1 union W2 is a subspace if and only if either W1 contains W2 or W2 contains W1. So either W1 is a subset of W2 or W2 is a subset of W1. So this is an if and only if result. So what we have to do for proving this? Now if part. Suppose W1 is a subset of W2, which means W1 union W2. If W1 is a subset like this, if this is your W2 and this is your W1, your W1 is contained in W2, so it's their union is equal to what? W2, and you know that W2 is a subspace of V, which implies W1 union W2 is also a subspace of V. Now secondly, if W2 is a subset of W1 like this, if your W1 is this and W2 is belong to W1, so their union W1 union W2 is equal to W1, which is a subspace of V, which implies W1 union W2 is also a subspace. So we prove here if part. Now we have to prove else part. Else part, which means we have given with W1 union W2 is a subspace, and we have to show either W1 is a subset of W2 or W2 is a subset of W1. This thing we have to prove. So let's take it in opposite way, like we can write W1 is not a subset of W2 or W2 is not a subset of W1. So here we can take some x belongs to W2 and that x does not belongs to W2 because there is a not condition. And from here we can take like some y belongs to W2 and y does not belongs to W1. So as you see here, x belongs to W1 and y belongs to W2. So we can write x belongs to W1 union W2 and y belongs to some W1 union W2. So from here we can write as W1 union W2 is a subspace. It is given here. So we can write x plus y belongs to W1 union W2. Now we can see there is a contradiction, as you know that x belongs to W1. So we can write here x belongs to W1. As W1 is a subspace, we have additive inverse of x, that is minus x also belongs to W1. Sorry, it's W1. So what we can write from here, if this one, so either from here either x plus y belongs to W1 or x plus y belongs to W2. So what we can write, this is x plus y belongs to W1 and this is minus x belongs to W1. As W1 is a subspace, so we can add these two, that means x plus y minus x belongs to W1. We can write here by commutativity addition y plus x minus x belongs to W1. Now by associativity we can write this one, and this is additive inverse, so we can write this as y plus 0, as 0 element is in W1 because W1 is a subspace. So y plus 0 is y belongs to W1. But we know that y from above condition, you can see from here, your y does not belongs to W1. That means we get a contradiction. So we can say that by contradiction, W2 is a subset of W1. And For other part, like if x plus y belongs to W2, and as we know that there is an element like y belongs to W2 from here. Now we can use this y belongs to W2, that is if y belongs to W2, that means minus y also belongs to W2 because W2 is a subspace, so there is an additive inverse. Now we can add these two by definition of subspace. So by associativity again, this thing which implies x plus 0 belongs to W2 and which implies x plus 0 is x, that belongs to W2. This is again a contradiction. So we can say that W1 is a subset of W2. So either this thing happens or this thing, which means W1 union W2 is a subspace if and only if one subspace contains other. So this result is very important. So if you find my video useful, then you please subscribe it. Thank you guys.